Hello, everyone. Welcome back to my live streams. I hope you're doing well today. So today I would like to start with something different. As I mentioned in previous live streams, I was thinking about maybe besides just, learning NIM and this, let's call it, not very exciting coding, maybe I should try to do something with games like Unreal Engine. I worked in a game studio a long time ago, and I know some things, not a lot, but I can get things going. So I decided that hey, maybe I'm gonna try to make a game in Unreal Engine because I just like the features and an opportunity to learn more about it. It's something that I know that I will be getting back to a lot throughout the years, even though I probably will never make any actual game. So yeah, that's the idea, to just get something like that going. And let me just prep my screen because I have like everything going on right now out of nowhere. Let's get rid of everything. Let's get rid of this and that. And we're actually gonna try to set something up. Let me switch to screen number. Okay, here's a screen. So let me just try to add some like privacy screen, okay? I'm gonna add a new source. It will be color source, game capture image. And we'll call it privacy screen or overlay. Just in case I can toggle something quickly. If I need to, do something you shouldn't see. So let's load a picture. Okay. We do okay, and we're just gonna extend it over some kind of area. Just in case it's a picture generated with ChatGPT, so it doesn't make any sense. Okay, and let's bring it a little bit up. Where on earth is this? Oh, okay. So we're gonna move it here, and here, and here. Nope, here. Okay. I just need to set up key on my keyboard, like, a MIDI keyboard that you can play on. I have it set up so that I can, blink myself away with a button, or I can't see now, but zoom into the screen a little bit or something, or switch to a different scene. Okay, so here, edit it, and I have this thing. No privacy will be for the left screen. Privacy overlay. Not move source. It'll be display source. This will be hide. While this thing here will be display source. Privacy overlay. Show. Right? Hide and show. So I do press number 4. Shows, doesn't show. Shows, doesn't show. Okay, cool. That works. And you can still, whoops. You can still see me. Great. So we have that set up, and yeah, I have like a zoom in. Dum, bum. Okay, so let's get to it. So let me show you what I mean, what I'm trying to do. So I'll start up Unreal Engine. I mean the thingy that the mode that it starts in. There we go. I'm going to just resize it and plop it here so that you can actually see it. Here's the zoom in. Okay. Okay, so now, first I'm gonna show you basically how to set up like a project from a template with Unreal Engine. So we actually don't need it. Let me just bring up terminal instead, because that's what we need. I could probably just grab one of those. Gonna go to D. Okay, we have our file explorer. I went to the D drive where I made a folder Unreal Engine. I'll actually delete all those tests because I was trying out what works, what doesn't work. File is open in a different program. Huh. Okay, there it is. Okay. So if I'm gonna start the Arc browser, I can show you the plugin. So new tab, it's nim for UE, as in nim for Unreal Engine. I think it's false spaces. There we go. It's this plugin, nim plugin for Unreal Engine 5 with native performance, hot preloading, and full interop that sits between C++ and Blueprint. So that's like pretty much the only plugin that allows you to use nim to program in C in Unreal Engine, which is actually awesome because not a lot of languages allow for that. And currently there aren't even like decent plugins for Godot 4, which is surprising. Somebody started it, but I don't think it's being currently maintained. I don't know. It's crazy. But there's this thing, and you can install it in an existing project somewhere here, but currently it doesn't work for me, at least. But what they provide is nim template project. It's basically a third-person project already with nim set up. You just clone it, run a few commands, and you should be going. So, yeah, I worked with the author a little bit to make it work with the newest Unreal Engine 5.4.1, and I guess it works now. So the way it works is that first we need to clone the repository. So I'm gonna copy this command, clones this very repository, and loads the submodules. So we can go here, and let me zoom in with this button. Okay, and here we should be able to basically right click, open in terminal. Okay. And here I should be able to easily do, let's just paste the command, right? We're gonna clone it. Should take a moment. Okay, we just cloned the template. Now what we need to do is basically go in there, because right now we have just that nim template. So we go cd nim template, and inside there we already have plugins folder, and inside of there we have nim for Unreal Engine. So we're in here. We have a lot of files here. What we need to do now is basically set up the NUE, new, which is nim for Unreal Engine. So we do nimble, new, and I would think for a little while. It's like create an executable to, I guess, keep building the thing. It's like a whole separate tool. Alrighty. So that's done. So when we will look at our files here, inside nim template, we have the plugins and we have nim for Unreal Engine. So here, at least on my computer, somehow it doesn't work. We need a file called nim for Unreal Engine .win, as in for Windows, .json. But we have only the sample that it came with. It should generate it, a proper file, but in my case it doesn't. So I'll just rename, copy and rename it to something appropriate. And now can do basically open in VS Code. And you can see that it has its own things set here, like a default. So we want Unreal Engine 5.4. And here we want D. It'll be UE for Unreal Engine. And that was called nim template, I believe, right? It's in nim template. Okay. So save it. That should be it. And now we should be able to continue because we have that file set up. So let's get back here. And all we need to do is basically run the file we just created, the new executable setup. And this might take a while. And it worked for me a few hours ago. I hope it's gonna work now. It should, I guess. I hope so. And this might take a while because it's actually building what this thing is doing. It's basically reaching out to Unreal Engine, looking for all the things in the code base to see what, types are available where and whatnot. And it's basically finding all the bindings and generating nim code for those bindings of C++, like on the go. So if you would add some new class in C++, this tool will automatically detect it. Oh, we have a new thing, and it will generate bindings for that. This is where Unreal Engine's like reflection system comes in, because Unreal Engine automatically generates all like special, descriptors of classes and everything for basically for the whole engine, as long as these are like engine classes inheriting from like U class, U prop, and all those things. So yeah, this is gonna take a while. So let's wait patiently. I hope you can hear me. I hope the audio works. Okay, there we go. Oh, so now it's running the nim template U project, run generate bindings. It actually opened up a whole Unreal Engine console with where it's when it's generating all those bindings. So yeah, after that, we'll be able to just start it up. Yeah, and this takes a few minutes, unfortunately. Now with live streaming, actually, it's taking extra long. Come on. Oh. There we go. Bindings generated. In the meantime, I can get myself a drink. Oh, are we finishing? Okay. And we're done. That's it. We can close the terminal. Now we can go back to our template and just double click our U project. And that should start up. Oh, there we are. We have our Unreal Engine project. And when we look around here, maybe better here. Let me just turn that on for a second. Where? Data, Unreal Engine. There we go. So basically, in our template, we have nim for Unreal Engine folder. And here we have our code. Right now it's just game.nim. And I'm like 75% sure that the game.nim is the actual thing that is going to, what do you call it? Is the actual like main entry file. So I should be able to probably just right click and open with code. There we go. Let me just see if this fits on the screen. So why do I even bother? There we go. So you can see that we have our config.nims, which links to all the, Unreal Engine related configuration where everything links to. Game.json, not sure what that's for yet. And we have a game.nim, and this is where we actually define our character. So in the Unreal Engine, if we go to Control Drawer, gosh, this UI is tiny for a stream. I wonder if I can make it larger or something. Didn't Unreal Engine actually add options like that right now? Like scaling or something? Accessibility, nope. Theme, user interface. Application scale. Oh, there we go. Look at that. I can make it larger. So let's do 1.25. There we go. Now it should be easier for one to see what's going on. So in our content browser, when we go to characters, and let's see which one. Mannequin Unreal Engine 4? Oh, third person. There we go. Okay, we go to third person. We have a blueprint, third person character. Okay. When we open that guy up, of course it opens on the wrong screen. And things are getting buggy. Ah, I see. The different screen resolution doesn't help. Okay, so this is blueprint only. Open full blueprint editor. Okay. Can I put it here? Yes. So this is basically inheriting from... Where do I check where it's inheriting from? Parent class, nim character. Open the source file. Oh no, it's gonna open Visual Studio. It shouldn't though. Because the way the nim plugin works is that it actually generates a DLL that's being hot reloaded on demand. But basically this is parent class is nim character. So if we go back to our code here, we have straight up view class A as an actor. We have nim character. That's it. We define everything here. We define what U props are available, that we have a camera boom, we have follow camera, we have whatever, mapping context for the input, and everything is defined here. We have default values for everything. And, you know, set up player input component, all the stuff with the new enhanced input. And we can define U functions. And it's interesting because you just define, okay, this is macro, and you just put in, procs inside, and that will be automatically turned into U functions, which is awesome. And we even define additional U class, which is a game mode that inherits from a game mode base, which is just nuts that you have all that inside nim, available through nim. So let's play that little part, right? When I hit play, we have our Unreal Engine 4 mannequin, I guess, because the template was ported from there. And when I jump, we have quite a jump, okay? This is some jump. But we can go here, okay? And we can say, maybe our jump Z velocity, instead of being 700, will be 1700. And our air control will be, 85%. And max walk speed will be 1500, so we just really fast, okay? I just saved it. What we need to do now, because in VS Code we have defined task, which is basically to compile it, which is, compile game. So I should be able to do Control-Shift-P and task, run task, and we have compile game, okay? We just click it. It's thinking. And I just heard the engine sound, the dee-dee-dee. And what should have happened already is that I should have it all compiled already. I start and there we go. We go faster. When we jump a lot, and we have great air control. So yeah, that's how easy it is to recompile. And as far as I know, this should have something extra fancy. I wonder if I can actually add another, what do you call it? Another class. Is it possible? Because here we have the U class character of a character, right? What if at the end here I'm gonna define another U class? I will call it my character, okay? Of, and it's the A&M character. So we're gonna basically extend it, right? And do we need to do anything here? we probably would need to do something. What is this? Re-instance? Config game. I'll copy that. I don't know what it does, but I'll copy that just in case. And what I'm also gonna copy is the defaults. So let's bring those back to normal, okay? 35, and we'll do 500 here. But what we're gonna do is we're gonna set those defaults here. I'm gonna defaults, and I'm gonna print them here, and we're gonna put them to those bonkers values again. So if that works, we just define another class. And is it possible that when we compile it, you know, run the compile game task, is it gonna work? Is it gonna let me switch that blueprint to the other thing? Okay. Compiled. We go back here. And when I run, I'm back to normal speed, right? Because we reverted those changes inside our class. But can I go here and do like right click now? How do you change the base class for the class settings? Parent class, nim character. My character. There it is. Look, my character. Okay. Compile of blueprint and person done. So we'll do save. We run it. And our defaults don't work, but the character still works. So at least that's that. I wonder why the defaults didn't work. I guess maybe things weren't exposed. Or you need to access the base components in some different way. Maybe that's the thing. Yeah, it might be the thing. Yeah. Don't know. But maybe during the live streams that I'm gonna continue with, I don't know when exactly yet. Maybe I'll be able to figure out, you know, how to make it work, because those defaults are here and they're on capsule component. Is it defined somewhere here? I mean, I don't see it being defined here. We have only camera boom, which is here, follow camera, and default mapping context, nothing else. So these are components from the whatever you call it, from the base thing. Does it mean that this thing here needs to be indented as well? Will that make a difference? I very doubt so, but this is my last try. After that, we're gonna go back to learning nim instead of figuring out Unreal Engine and nim together, which is like, you know, oh, look at that. Unreal Engine process has crashed. Oh, that's what it feels like working with Unreal Engine. Close without sending. That's too bad. But hey, the thing worked, right? It compiled. So we should be able to... how was it? Start a game. Let me quickly do that again. This one. I had to print some labels for those buttons. And it's running, starting up. We'll see if it still crashes. Create export, failed to load outer for resource arrow, follow camera, collision cylinder. What the hell? Why is it on the wrong monitor again? Okay, something didn't work, right? When we start the game, we don't have our character. Okay, I see. So it looks like our code just stopped working if we added those two spaces. So I presume that because we didn't have this indentation here, the defaults were just ignored. And it just stopped working. So what happens if I'm gonna remove all this? Okay. Because we're not defining anything here, right? This will probably just for U props. Although the U props is here. I don't know what that's for. And then we just have the default, but without the indentation. So I don't know. I'll give it one more try. And let's switch to nim before everyone falls asleep. Thinking. Okay. Things didn't crash. Can I start a game? No. Can I open my blueprint? Could not be loaded because derives from an invalid class. Look at that. And hasn't been removed. Oh, can I change the parent class here or something? How does that work? Don't know, but things changed and things don't work anymore. Very interesting. So I guess I could just go and undo things to the point they were initially with this, I don't know, weird quirks. But I am hoping that the author of the plugin will help me figure out how to add that plugin to an existing project, because I have an idea for a game that it'll be fun to make from a first-person perspective. That's something I prefer. So this is nim for UE. When I run all that on an existing project, it just doesn't compile. So that's the thing. Okay, it is built. And no, we don't have the parent class. So we just broke the whole thing. I'm sure there's a way to revert things, especially if we would be using some version control, but oh well. Let's close it up and let's finish it for today, so that we're not dealing with Unreal Engine anymore. You know, it's not supposed to be today. Before next stream, I'll probably announce on my channel when I will try to continue with that. So our agenda now is that we're gonna take a little quick look at the tutorial part 1, you know, the next part of it, because last time we finished right before arrays. Okay, we went to advanced types, subbranches, sets, bit fields, and now we have arrays. So let's see how long this thing is. Let's say we're gonna go all the way to open arrays. We're just gonna keep going. This way we keep refreshing our memory on those subjects. And I think we'll be using sequences in array today, as we want to implement file reading and writing, and we'll need to deal with, you know, sequences or arrays of bytes as we're reading a file. So it'll be a good refresher. So arrays. An array is a simple fixed length container. Each element in an array has the same type. The array's index type can be any ordinal type. Okay, arrays can be constructed using the square brackets. So we defined a type int array, which is basically an array of 6 elements from 0 to 5, including 5. And those elements are of type integer, okay? So it can hold integers, 6 integers. And then we create a variable of that type, right? And there's nothing stopping us from, instead of making this a separate type, just, you know, take this and shove it right here. And this looks so we can assign it. We can construct it using those square brackets. And then we can iterate over it from low to high. But do we have to iterate it like that? Can I just... let me open the other project. What could we work with? CommonFs, right? Is that the correct CommonFs? No, that's not the correct CommonFs. Ay. Because I managed to install the nim on Windows finally. It didn't complain about big angry Trojans anymore, so that's awesome. So I'll go through changes, what I changed in the libraries after we go through a little bit of the tutorial. because I did change a lot. Okay, here we have our quick fun. So let's replace it with our array, right? So we're basically going through the range of this whole thing. Can I specify that instead of this for low to high, can I just say for x? Okay, that will give me the values, okay? Ah, I see. So low, yeah, this is the thing I'm constantly getting, like forgetting about, is that if we go low x and high x, the low x, it doesn't return the first or like lowest element, the first element of the array. It just returns the lowest index of it, and high, it returns the highest index. So basically we're saying n from 0 to 5, right? So we can see that this is translated from range 0 to 5. The compiler just sees that, like, oh, okay. You don't need to call that during runtime. We'll just inline it. And therefore we have an index and we can call it like this. If I purely wanted to iterate over those and not bother with the whole accessing the array, I could just do, for, and instead of I, we'll call it value and x, and we'll just echo value, right? And we do it, we run it, and oops, wrong. We run it and we printed them out as well. So that's the thing I keep forgetting with this low and high. It's just a strange concept for me a little bit, because usually in programming languages, when you want the lowest element of an array, it will be always 0, right? It's always 0. And the highest will be just the length of the array with -1. But here suddenly we have like, hey, this could be an array of indexes of from -20 to 200. Just, random range. So that's the confusing thing. The notation xi is used to access the ith element of x. Array access is always bounds checked at compile time or at runtime. These checks can be disabled via pragmas or invoking the compiler with the bound checks off command line switch. We hopefully will never ever do that. We won't ever need to do that, but I guess if you have like really high performance code, not having those bound checks can speed it up. Arrays are value types like any other nim type. The assignment operator copies the whole array contents. Exactly. So if we have this thing here, right? And after that we want to do var y is x, okay? Y suddenly is a copy of x, okay? That's the main difference here. So because it's a variable, I can do y0 is 100, right? And then I can print out both of them. Let's do this. Let's just not print it out here. We'll print out x, and then we're gonna print out y. And let's do echo x, and then echo y. And when I'm gonna run it, x didn't change when we changed this, right? Because we have a copy here. We straight up copied it. While y is, the first element is 100 because, of course, we copied the whole array. So that's another thing to remember. Because in many languages, the moment you have a little bit more, a little bit larger construct, they all often are, passed as a reference. For example, in JavaScript. In C# you have it a little bit more complex because I believe array is a value type, but something like a list isn't anymore. But I'm not even 100% sure right now. Okay, the built-in len proc returns the array's length. Low A returns the lowest valid index for the array, and high A is the highest valid index. So it's important to remember that the length of an array is different than the highest index because the index can start somewhere else. So that's the tricky part. So it's a cool separation, I'd say. Okay, we define enum direction and enum blink lights. And then we have level setting. We have an array where indexes are from north to west, which is basically the whole of direction. All the directions are the index, and the values are blink lights. So we basically have the status of lights for each direction. And then we create basically an instance of that array. And then we can set that, hey, the north is on, the south is this, east is that. And we can basically print them all out. And I guess we didn't set the west, so west should be the default, which would be off, because that's the first element, is 0. Okay. We can echo the whole thing. We can echo the lowest index of it, which will be north. The highest index will be west, and the length will be 4, because 1, 2, 3, 4. Awesome. The syntax for nested arrays, multidimensional in other languages, is a matter of appending more brackets, because usually each dimension is restricted to the same index type as the others. In NIM, you can have different dimensions with different index types, so the nesting syntax is slightly different. Building on the previous example, where a level is defined as an array of enums indexed by yet another enum, we can add the following lines to add a light tower type subdivided into height levels accessed through their integer index. Oof. So we have light tower. Okay. Oh, I see. We have just a bunch of lights stacked on top. So we have an array from 1 to 10, where each value is this level setting, which is another array of all the directions. Okay, I see. And then we basically say, hey, give me which level setting. This time, in this case, the first element, because it starts from 1, not from 0, in this case. And then direction, and we can set it. Okay, and len tower will be 10 elements, because it's the length of the tower, and length of tower 1 will be the length of the actual level setting, which will be 4. Okay, and even prints out the whole thing. And something like tower northeast, yeah, of course it doesn't make sense. These don't make sense, so. Okay, this is simple enough. I guess defining those subtypes, like type aliases, is really helpful. It's like a little bit different way of programming, because, a lot of type systems, they for some reason don't want to let you define aliases. That's one thing that I'm upset about C#, because it will be so helpful to just be able to define those type aliases in a nice and neat way, just like a NIM. And this way, suddenly C# code doesn't take up, you don't need like super extra wide row of monitors to see the end of the line. So yeah, that would be nice. And note how the built-in len proc returns only the array's first dimension length. Another way of defining the light tower to better illustrate is its nested nature would be to omit the previous definition of the level setting type, and instead write it embedded directly as the type of the first dimension. Yeah, so we can just do that. It's just getting hard to read at that point. It's quite common to have arrays start at 0, so there's a shortcut syntax to specify a range from 0 to the specified index -1. Yep, we just specify 6. There are 6 elements, 0, 1, 2, 3, 4, 5. and that's it. So this is like, just like in the regular programming languages that don't deal with crazy indexes. Okay. So we went through arrays. That's awesome. Sequences. Sequences are similar to arrays, but of dynamic length, which may change during runtime, like strings. Since sequences are resizable, they are always allocated on the heap and garbage collected. So that's important. Arrays are on a stack, sequences are on a heap. Unless you make a reference to an array, then it's going to be on a heap. Sequences are always indexed with an integer, starting at position 0. So that's the difference from arrays. Arrays, because we know exactly, we need to specify how many, how we're indexing them. Therefore, this index needs to be known at compile time. While sequences, they can be resizable, they're dynamic. We can't specify that. It just starts at 0 as everything else. The length, low, and high operations are available for sequences too. The notation xi can be used to access the ith element of x, so everything works the same. Sequences can be constructed by the array constructor in conjunction with the array to sequence operator. There we go. So that's an operator. So when we call this, we're first constructing the array and then converting it into the sequence. Okay, that's funny. Another way to allocate space for a sequence is to call the built-in new sequence procedure. Okay. A sequence may be passed to an open array parameter. Okay, we'll learn about open array later. So yeah, we created a variable of type sequence that holds integers, and we just created one that has 6 elements. Sequence variables are initialized with the @ and square brackets. And the for statement can be used with 1 or 2 variables when used with a sequence. When you use the one variable form, the variable will hold the value provided by the sequence. Excuse me. The for statement is looping over the results from the items iterator from the system module. But if you use the 2 variable form, the first variable will hold the index position and the second variable will hold the value. Here the for statement is looping over the results from the pairs iterator from the system module. So here is over items, while here is over pairs. So items will be just return values, pairs will return index and the value. So I guess we have a third option. Okay. Let's just replace all this, and we need to grab this thing as well. So, well, where did it go? I thought I copied it. Okay, we have this code here. So we can also iterate over just indexes. For I, n, and we do low of, what is it? Low of, let's say, x to high x. And it should work. Okay, let's try to run it because anim command not found. Where do we have anim? What on earth happened? Oh, I had something typed in. Declared identified 2. Not 2, ... That's Copilot messing things up. Oh, there we go. And we're able to iterate over just indexes as well. So that's like a third form though that we need to remember that if you want to iterate over the index, you can as well. You don't have to just get this and that, depending on what you need. But most of the time when you iterate, you want the value, or you want the value and index. You rarely want just the indexes, but if you have to, sure, go ahead. I presume this will be a little bit more optimal in extracting the value I presume, but maybe it's exactly the same. Okay, so we went over that code, and wow, we're going fast. Open arrays. Note, open arrays can only be used for parameters, and parameter, as was mentioned somewhere, a parameter is strictly a parameter of a proc, of a procedure. So basically, open arrays can be only used as input to the procedures. It can be used as an output, they can be used as a run variable, nothing like that. Often, fixed size arrays turn out to be too inflexible. True. Procedures should be able to deal with arrays of different sizes. The open array type allows this. Open arrays are always indexed with an integer starting at position 0, okay? The lang, low, and high operations are available for open arrays too. An array with a compatible base type can be passed to an open array parameter. The index type does not matter. Oh, the index type totally doesn't matter. But I guess if I would try to put something with an index from 0 to something, would not work, I presume. So let's see, we created a variable. First one is fruits. It's a sequence of strings. And the second one is capitals. It's an array of 3 strings, okay? 0, 1, 2 will be the indexes. So we say that capitals, we just set capitals for those strings, and fruits, because it's a sequence, we can do add and add. Did we skip the thing with sequences where they were saying that we can add stuff? Huh. It's not even mentioned that you can add stuff to the sequence. Very strange. Yeah, you can modify the sequences. So then we define a proc, okay? And the OA parameter is of type open array that takes strings. So it's like a sequence. We don't define the length of it, but it should act as, it should accept both sequences and arrays. And all it is just returns the length of it. So we can basically shove a sequence and shove capitals in it, and it all just works. So very handy. This way it's easier to write a proc that will accept a variety of sequences or whatever arrays. And this way it's a little bit safer. But I want to know if when I'm gonna make a weird index, if it's gonna work or not. So this is good, right? I'll run it and it's happy. But what if I'm gonna say that this is from 1 to 3? Okay. It worked. From -1 to -1, 0, and 1. Save. It works. Can I iterate over them? How the hell could I do it? So for I, value in OA, we should have a pairs, and we echo that element, and the index is in the value, right? And then we return the length, because why not? So let's also echo this, and I will start it. And let's see what happens when we run it. So the first one is the sequence, right? The sequence is 2, element 0, and 1. Well, length of open array is 3, and it actually re-indexed the whole thing. So we index from -1, 0, and 1. These were our indexes, because if we're gonna copy this thing, right, and just put it here after we define capitals, we'll just do echo capitals, right? I guess I can go through pairs of capitals. Yeah. We save it. And we already, this is just telling us ranges from -1 to 1. So when we run it, the capitals element -1, 0, and 1. While inside of our proc that uses OpenArray just magically reindexes it. Huh. I didn't expect that. This is very interesting. So suddenly, whatever index you had prior to passing it to that proc, it's different. So if I passed an array, right, and let's say I wanted to also pass an index to it, suddenly it doesn't work. I would need to straight up say, let's say that it takes the, some kind of index, and that'll be integer. If I wanted to specify that I want in our capitals the integer to be, the second element. I mean, if that would be a second element, I would just do, hey, this is the number 1 will be the second because 0, 1. But if I had not which element it is, I had, the value that, hey, it's index -1, because I could have from -10 to 10, right? Or whatever else, some long index. Let's say it's -1. That means that I need to take my -1 and then what? Get the subtract the low of capitals to like kind of bring it back to what it should be, and -1 minus -1 will be +1, which would be 0. That will be the first element, yeah. I'm curious how it's gonna end up in practice because it's very strange. Very, very, very strange. Alrighty. So we went over the examples. The open array type cannot be nested. Multi-dimensional open arrays are not supported because this is seldom needed and cannot be done efficiently. Okay. Sure. Makes sense. Okay. So that's enough for tutorials today. It's 11:33 here. So let's close that off. I'm just gonna write down that we need to continue with our args next time. And now I can show what I did to the existing library. So we have the CommonFs. Let me also open up quickly without you looking. I'm gonna open up the other library, which is the OsFs. Okay, there we go. I can make it zoomed in as well. Okay, there we go. So, going back to our CommonFs. So I did a few things. I cleaned up the settings and tasks a little bit because it was becoming a mess. In the settings, I primarily, for an in project, I basically specified that source/commonfs.nym is our entry point. I believe this is used just for the VS extension, so no big deal here. And I also added the tests to be one of the entry points too. And you can see that the tests are in the source, not in the test directory. And I will get to that in a second. The other thing that I did is that if we'll get to our CommonFs, so what I did, I basically added up here, right? We had the file defined. I also defined the object directory. And this way, when we create the directory, we can get like this reference to a directory or to a file. It's just a handle that holds the path to it and which file system is referring to. And because of that, I also needed to add some procs to that. So we have the directory operations. So I added, getting a name, checking if it exists. That will call the, the main file system, check if directory exists. So, nothing really implemented here. As for the name, we just need to make sure that if it's a root path, just return the slash. If not, return the last element of the path. So that's something simple. And I was able to extract the procs for getting the file system and getting the absolute path out of it. So we have one proc that will work for both directory and file, because turns out in nim, you can do something that you could do, for example, in TypeScript, where you can define that the type is directory or file and work for both. So that's the whole idea of the type system, which is a little bit more like duck typing instead of, it will check if it compiles. If something doesn't compile here, only then you're going to get the problem. It's not going to be complaining like, oh, you need to check if it's this or that first before you can access the .fs or whatever. It's going to work, and it works, and it's just glorious. Yeah, so yeah. It's now I'm seeing returns the file system object the handle belongs to, because it's not just file or not just the directory. Okay, so that will be pushed just docs, change it in the docs, and that's it. That's all that was added here. The rest was already in here. So that's that change. And the other change is that, all the tests are still here, but previously all the tests that, basically CommonFs on its own is just an abstraction. So we can basically check the functionality for exists, because this is dependent on, are we checking it in memory? Are we checking it on the actual file system? So this is dependent on the actual implementation. So only the implementing library can actually check if those operations work, because that library is implementing that functionality. So we'll go to, fs file exists, which is somewhere up here. File exists, right? It basically, all it does, it calls the implementation, but implementation is a method that isn't implemented here. It's implemented in the file system OS. And because of that, all the tests that we're writing so far, they were inside the OsFs, okay? Because here we have the implementation. The file exists, right? The implementation, and we're actually using just straight up whatever nim provides, so it's super simple. But somewhere else, like create file implementation, we're doing a little bit more. But the thing is that if we have all those tests right here in this OsFs, and we finished off, we're happy with it, and now we want to move on and implement the in-memory FS, we'll basically need to copy paste all those tests. And they shouldn't really differ in any way, because all the library is supposed to be used exactly the same way, no matter if we're dealing with file system, a real file system, or in memory on, I don't know, S3 bucket or whatever. So it didn't make sense to hold those tests in OsFs. So what I did is I moved them all into the CommonFs, but instead of being in the test directory, they won't be here, because test directory is whatever we can run on the actual library. Because if I'll go and to the terminal and run right here, nimble test, it just runs tests that are in here. It searches for all the test files. But in source, I created like a little submodule called test nim. And right now, it exports a single proc, which is verify implementation. And it basically asks for a constructor, which is a little procedure that doesn't take any arguments and returns an instance of a file system. And then basically calls verify this, verify that, verify create directory. And all those implementations are here inside private. And all the tests are here. Turns out that you can basically wrap all the tests in a simple procedure and just paste them here, and they will work. The only thing here is that we're taking the constructor that would return file system, and when we're constructing the file system for each test, we just use the constructor. And because of that, now inside our OSFS, the implementation of the CommonFs, in our tests, we have one test, which is 3 lines of code. Import the tests from the CommonFs, and then import the new OSFS, which is the constructor that OSFS creates, and we call verify implementation, and we'll give it the constructor. Or if it's something more complex that needs configuration, we could just do it here to manage whatever. And that's all it takes for this library to verify itself. We will move on to in-memory FS. We write the implementation, we just do verify implementation, and all the tests will be running on an instance of the in-memory file system. So basically we have inside CommonFs, we have like a common testing solution for the whole thing, which is absolutely awesome, at least in my opinion. So yeah, that's fun. And the other thing that I did, I figured out how to actually make it where OSFS, when it defines that it requires CommonFs, that I'm working on a local copy. So inside the CommonFs, we have the CommonFs nimble. So all the stuff is the same. The thing that changed, I added a task, I call it dev uninstall. And that dev uninstall, basically, the idea is that it will remove the package from being installed locally. So, if you want, you can switch to normal, what would you call it? You could switch to normal thing that you actually download from Git over from Nimble directory. So it calls Nimble uninstall. And this I is basically to force it to uninstall it. And of course, yes, whatever, it uninstalls CommonFs. And then we have dev install, which first uninstalls it, and then it just reinstalls it. So reinstall the package. So if I would, for example, let's go to OSFS. It's right now, it has some version of it. So if I'm going to run the tests, which will be, where'd it go? Nimble test. Okay. Oh, that was fast. It ran all those tests. And all those tests are defined in the CommonFs, of course, which is awesome. Oh, look at that. OSFS, remove file. So let's fix that. Because we have, this should be implementation, the generic one. So I found the problem. I can go here to CommonFs, find it. That was remove file. So we go to test remove file, right? There we go. And looks like I already fixed that. So voila, right? I'm gonna save it. And then what I can do is basically run nimble dev install. That will uninstall it, reinstall it, and already finished. And I can go back here and rerun my test. there you go. Change is already in there. So this way we can iterate locally really, really, really fast. Where these are in separate directories, they are separate repositories, and I don't need to, because normally I would need to basically commit changes on CommonFs, make a new version, right? So that I can go here to OSFS, pull that new version, so it's gonna, be updated from GitHub, whatever, or from the directory. And suddenly things will be slow and it will have million little tiny versions. This way it can work locally as we're developing both libraries at the same time. When we'll be implementing a memory file system, we won't worry about it because the only thing we'll be doing is, focusing on the in memory and not the other one. So these are all the changes. Okay, let me just remove that wall of law because that's not supposed to be here. Okay, I'll remove it. We'll reinstall it and done. Update it. Cool. So now what can we do today? So today it will be nice to, let's go to our README. It would be nice if we could implement for file operations something of that, like reading everything to a string and maybe writing a string or something like that. I would start with reading, maybe string and then bytes, and when we have that ready, we'll be able to, have fun with it, and we'll see how much time it takes us to do that. I presume not a lot. And then we're going to move on to writing, and yeah, let's try to do that. So something like read all, okay? Read all. So let's remove all those tests. Let's go to our CommonFs. I'm gonna reduce the font a little bit because it's just too large for me to even see anything. And how do we sort it out? We have our types, right? We have our current directory operations, file operations, okay? So maybe here we can define proc. And that was read all. And the idea about it, right? The name read all came at some point from the actual NIM standard library because it's that's how it's been defined in the thing. So let's make it exported, right? Self file system, and we need to give it a path. Okay, what file we're reading, and this will be purely reading. So I guess we don't need to specify anything else, and we're expecting a string as a response. Okay, and this is already telling us that it should be any of those. Sure, could be library error, could be file system error, or could be invalid path error. All of those are valid. Reads the contents of the file at the specified path and returns it as a string. If the file doesn't exist, it raises the file system error. Okay, so that makes sense. And what it did what we do everywhere else, where we make sure that we have the absolute path from the path, and we basically instead of raising an exception here, we should basically do self read all implementation, and we give it the path because we want the OSFS to implement that. So let's specify that method. Okay, read all implementation, and that'll be self file system again, and all those things. Yeah, this doesn't need to raise things. It's the implementation that does that. Okay, and we just throw method read all hasn't implemented yet. Okay. Gosh, the squiggly lines everywhere, disgusting. Alrighty, so we just defined a read all, and that we want a string. So what we can do now is reinstall, and instantly, we can go over our, maybe we should do TDD. How about that? Test-driven development. Maybe we'll write a test of that thing first. Hell yeah, let's do that. Now we have capacity for that. Something that we can imagine we would do in the future, or somebody implements makes other implementations. So we're gonna go here and we're gonna create a new file, test read all.nym. Okay, so be our test. And let's open some other test like remove file. Okay, we'll just put it aside and we're gonna implement it. So we can basically, what I learned, we can just copy the whole top because we need to import everything. Verify read all implementation. Okay, we take a constructor because all we need to do is have access to a file system, and we do suite, and this will be implementation, and this will be read all. Okay, so it's easy to find. And what we get the test directory and the variable to the file system, the current one for a test, and we just do the standard stuff. Setup, create directory. Yeah, so we have basic setup where we created our test directory. We use the passed on constructor to construct the file system implementation, and we just remove it at the end. And from here we can just write the tests. We have a message from Evan M55. Hate having any squiggly lines in my program. Drives me crazy. Drives me crazy too. The problem is that in language right now, it has this, there's this, many languages have something called language server, and that basically allows your IDE to verify if things are correct, where the errors are and whatnot. And on top of that, Nym also has something called Nym suggest, which is like extra layer on top that's specifically for VS Code. But the thing is, it's very slow, or just straight up gives up. Like, you know what, this shouldn't be here. Like, this complains that expected to closing bracket, but got a queue at proc. Like, really? Everything's fine here. Or no, it's not actually. Look at that. I'm being the stupid one. Now it's good. Oh. Hilarious. Okay. So getting back to our read all. So the idea would be that what do we need to test? Let's just write down the names of tests. The first test will be should read contents, the full contents of a file. Okay, that's the main thing. Should return empty string for empty file. Also, not a big deal. And such as should return empty string for non-existent file. That's the thing. I think that if we want to read a file and if it doesn't exist, we should throw an exception. So should throw error if file does not exist. Okay. And should throw error if path points to a directory, because we can't read that either. What else could there be? I guess we could have test cases that operate over something like, is it a binary data or something? But I think we're gonna get to that later. Let's just cover our bases. The thing is that so far, we have all those variants. If it's a relative path or if it's absolute path, all those things. So I'd like to have those tests properly everywhere. So I will add it at least for the first one. So should read full contents of a file for absolute path, okay, or via absolute path, and then will be one via relative path. Okay, and the rest I don't care. It should be good enough. So let's implement those tests. It should be relatively easy, right? So the thing is that what I did so far is I made, like, you know, we define our relative path. So let's call it text file 1, okay, and .txt. Why not? Because this will be something simple. And the absolute path we just constructed here. And then we need to create the file. So I could use a NIM's standard library to do that, but hey, we have the other parts of the whole what do you call it? All right, we'll need to actually write to a file. Yeah, let's write to a file. Quickly, I remember one of the tutorials was describing just that. So if we're gonna go to our docs for nimlang, we should have, I believe this was nim by example. I was just editing that video like yesterday. Nim by example. Files. Writing into a file. Literally, write file, the path, enter text. Perfect. So this would be write to a file, okay? So let's do, let text will be hello world, sure, why not? Standard. And we write to a file and we'll give it the absolute path. Absolute path.string. I believe, right? This expects a string, not a path. So we have the file written, okay? So now we need to test if we actually, you know, get the proper result. So what we can do is check, and we do file system.read all. We do path absolute. That's what we provide, and it needs to be equal to the text that we have inside our file. Okay. And then additionally, because additionally we should have defined something similar like read all. Let me copy it with this whole thing on an actual file. Okay, so if we have a handle to a file, we should just call it read it and not even provide the path, right? Is the content of the file and returns that as a string. And that is it. We just need to do self as in the file dot file system, because we can get a file system, and then we have read all, and we can provide its own absolute path. So this way it's done. So if we want to test it, we also need to get the that file is file system dot get file handle, and we just give this absolute path, and we do check file read all as equals the text. So this is the alternative way of reading. So this is a test for reading, okay? And we can copy and paste it. We'll just need to make sure that we have a relative path that we're using. So when we write file, it's all the same. Let's do hello there instead. And this will be text file 2, just in case, so that they don't collide. And how is my test file? Okay, because I also do those read all test. So here, when we check file system read all, we should provide the relative path, but for that to work, we need to first do file system dot set, the current directory is the test directory path, right? Because it's without the relative one. So now we just provide a relative path, and when creating the file, we also provide a relative path, and it all should work. Okay, and we can get the absolute path when we'll be testing for an empty file. And because of that, we won't be defining any of that or writing file like that. We'll just do file system dot create file, and we just give it absolute path, and we can actually do let file is here because this should return the file. So we won't need to call it here. And this should return empty, and this should return empty as well. So that's how quickly we can write that test. I hope I'm not going too fast. I'm kind of doing that for myself, but also if somebody wants to watch, enjoy. Or not enjoy, you can complain to let me know that I'm doing something wrong. Okay, and let's do should throw error if file does not exist. So that was 1, 2, this one was file 3, okay? So we're gonna get this thing again. We have relative, that will be 4, and absolute path. And instead of creating a file, we won't create it. We make sure we can actually do check fs file exists. Path absolute is false, so we can just do check not file exists, okay? And I can just do that. This is nicer. Okay. Create. Yeah, let me just fix those things. I prefer that kind of syntax. And get file handle. Okay. That looks nicer. So we have this. We check for sure that the file does not exist, because if it exists, there's something wrong with a test. And then if it does not exist, we can do expect, and this will be the catchable error. We expect to get any kind of error right now when we read it all, and we discard the actual value being returned, because we don't need the value. So let's discard that, and that should throw an exception, and the same thing should happen for this one, where we will get the actually we should get the file, let file, where was it, get file handle. That should succeed without anything, right? So that's that. We can just get a file thing here, and then we can basically do expect catchable error when we do discard file read all. Okay, so that's that test, and we have one more test to implement, and we will be able to actually implement the actual thing, and it should be automatically tested by FSOS, which is awesome. Should throw error if path points to a directory. Okay, so we basically copy the whole thing, but instead of checking if the file does not exist, we need to do text file 5, or let's call it some directory. Okay, and we will do file system dot create directory. Okay, and we give it the absolute path, and we check if this should actually do let directory is, and we can do check directory exists. Okay, that's as simple as that. And therefore, when we try to read from it, in both cases, it should fail. And that's it. That's all the tests that we need right now, I believe. So what we can do is basically make sure that this test is being included. So we go to tests, we import private tests, and that was the file exists. And we can basically verify file exists implementation. We give it the constructor we got here, and that's it. We reinstall the library, and we can go to our OSFS, where when I will run the tests now, we should get exception. We should. Well, we aren't. Why? Nimble test. What's going on? Why aren't we getting any exceptions? We are on Ubuntu, so that's good. Verified exists. Test file exists. Oh. Yeah. It's all here. Okay. Not sure why it doesn't work suddenly, out of nowhere. File exists, remove directory, create directory, all that. But the newest one isn't running. Oh, because I did file exist. So let me read all. Okay. I'm a moron. Read all implementation. Jeez. I'm too much of a hurry. That's the problem. I feel pressure from the live stream that I need to keep going as fast as possible. Okay, nimble test. There we go. Execution failed. Error. Invalid indentation. Oh, that's new. Okay. Test read all nim 27. So let's go there. 27. Where is it? 27. 20. Oh, look at that. I forgot about all the colons. Or, yeah, these are colons. Every time I hear colon, I just think of an organ. Okay. 1, 2, 3, 4, 5. 5 tests. Reinstall it. Get back here, run it. And what now? Ambiguous identifier, absolute path. Huh. No side effect. Absolute path. 23, 29. 23, 29. It does expect a path. Where's our tutorial? Doesn't expect a path, but absolute path. Oh, path absolute. See, I'm making mistake after mistake everywhere. That's all this. Hopefully I won't make so many mistakes in the actual implementation as I'm making in all the tests. What now? Okay, now looks like we actually ran through the tests. Not implemented, not implemented, not implemented. So that's awesome. That's what we want to see. See all the things fail because they are not implemented yet. And that's great. And yeah, that's all of it. So basically, if somebody will want to create their own implementation of the thing, all the tests will just start showing, hey, not implemented, not implemented, not implemented. So let's implement it. So let's go to our CommonFs, and all we need to do is copy one thing. Read all. Let's copy this method here. The rest we don't care about. And here on our OSFS, we can just paste that method down here. Okay. We have the implementation and self OSFS. Okay. And return string, and we don't need any of those because it's not a base anymore. All the things that it could raise aren't supposed to be here anymore. So that's great. So now what we can do is basically read the file. And I believe in our tutorial, we also had that thing, right? Reading a file. Read entire file. Read file, okay? Let's just do that. Let's copy whatever the simple solution is. So return read file, and we'll just give it the absolute path. Dot string. And save it. Read file can raise unlisted exception IO error. That's it. So we will need to basically throw the file system error, right? So let's do try. We put that here and accept IO error. Ooh, IO error as E. And we just do raise new exception, file system error, and we pass on the errors and stuff, right? This is the same thing as up here. Yeah, that's it. We save it, and I don't know what it's complaining about. Ref object can't be raised. I think that's just, you know, bunch of bullshit. Okay, let's see if our tests start passing or something. Let's clear the thing, and oops, not that. What the hell? Nimble test. Ha! All the tests passed. There we go. Everything. So it works how we specified. Great. So in CommonFs, we can go to README and basically check off read all, okay? And let's commit all those changes in the meantime. Let's open up Git-Kraken. And push all the changes. So, CommonFs, what we did here. First I recall we actually renamed those two little things, like remove directory here and remove file here, just to fix it. So it'll be fix valid, whatever, fix comments or docs. Sure, that's good enough. Not very descriptive, but oh well. So then what we did is in CommonFs we just defined all the read all, and we created a test for all that, and we attached those tests and we checked the box off. Okay, so implement read all. Okay. Push, and we'll also go here. Why the hell do I have this thing? And here we basically know OSFS. We basically did, yeah, implement. The hell? Oh, test implementation. That's a binary file. That's the thing that I don't like. When the test fails, the binary for the test isn't removed. Like when the test ran properly, all the binaries for, it's compiling a test, it compiles it right here, and then it removes the binary afterwards. But here it doesn't, so that's like sucks. I need to delete them manually so that I'm not committing them. So OsFs basically implement read all IMPL for implementation. Okay, that's it. Reading all of files is completed. All of it as a string. So let's continue to the next one. So we saw that writing should be really simple if we give it a string, because we can go to our test, right? And we have just write file to what file and just what we're writing, and that's it. It's that simple. So how about we implement the same thing, right? So in CommonFs, we have read all. We'll define proc write. What do you want to call it? Write. Okay, sure. In a file, right. Self file system. We'll have the path and the contents as a string. But I don't want to do just that. I want it to work like the echo function, which is basically var args. So could I do var args? And it was something like string, comma, and the operator? I think something like that. And that should take care of the whole content. Let's do, yeah, that's it. It can raise file system error, exactly. And I mean, this write itself doesn't do that, okay? All we care about here, writes the provided content to the file at a specified path. The file does not exist. If the file does not exist, it raises the file system error. So that's another decision point. So when we're writing to a file, do we want to already exist, or if it doesn't exist, it should create it? I think it should create it because that's the implementation of write, right? Of the write itself. And here, let's look at that. Write file. Will we get docs? No, we won't. And control click doesn't work either. Oh well, but in this case, the file didn't exist. We created it by writing. So let's not do that. It should, if the file does not exist, it will be created. Okay. Get absolute path, and we do write implementation where we give it the content. So that's great. So let's do the method write implementation. And wait, write needs to be exported. And it will be self file system, absolute path, and content will be again those vargs. And this one can raise both errors, okay? And just method write hasn't been implemented yet. Cool. We have our closing parentheses and everything is in place. So that's good. So now we move on to the kind of boring part, but also the most code, which is writing the tests for that. So let's actually add them ahead of time here. Tests, it'll be write. Okay. And we'll have this thing verify. Write implementation, save it, and we can straight up go and create it. New file, test_write.nym. And we can just utilize what we had in read all. We copy all the way here and verify write implementation. And test directory for it will be write tests. And everything stays the same. So now for testing, should write to an existing file via absolute path. Okay. Let's just ignore that. And then we should have test. We are relative path. So we have those two things taken care of and verified. Then should write to a new file in both cases. And then we need to do test should allow writing multiple, what do they call it, elements, right? Because we have like an echo. Should allow writing non-string elements. That's another thing. We'll take care of it in multiple elements, right? Let's not do too much. And then should throw an error when writing to the directory, because that's another thing. And test should create empty file when writing nothing, or empty string. Okay, that's another thing that we need to take care of, because we can pass in an empty string. And then what? I guess we'll be able to pass an empty string or empty strings, whatever. We're writing empty content, because we could concatenate multiple empty strings, and then it still should just create an empty file. Okay. And the question here is, does it append or does it replace a file? That's a good question. We should have the same thing as the as the write thing. So let's just do test should overwrite instead of appending. Okay. Let's just do that. So we'll again start with the simple stuff. We have this thing should write next to the file. So let's do test string number 1. Okay. We'll just call it very uninventive name. Let's just make sure we have those columns ahead of time, because I didn't like that problem last time. Let's give ourselves some room. Okay, so should write. So we get the paths, right? We create the content, and then we need to check if the file exists, or like make sure the file exists, right? So we do let file, and we do fs create file, and we just give it the absolute path. And then we need to, let's do it file1, okay. We can do basically check file1 exists. And if it exists, we basically want to write to it. So we'll do fs.file1, write. And we give it the absolute path, and content will be just that content, okay? Why doesn't it like fs? First path absolute content. I want a first mismatch. What is going on? Right. File system, path, and contents. Not sure right now, but maybe the squiggly line will go away. I hope. I'm not 100% sure. Huh. We'll see. So we write here, and then we need to basically check file one read is the content, okay? We need to make sure that the content stays the same. And then we're doing let file2 is create file path absolute as well. Oh, we need to False relative 1, absolute 1. Need to have variance for all that. Absolute 1 and this absolute 1. Okay, file 2 is create file absolute 2. Okay. 1A and this would be 1B. Okay. 2, 2, and 2. And we need to check that the file 2 exists. FS right. We do that. Actually, no, this would be file 2. Right. And read all. Again, for both. Oh, I guess we didn't mention right in here, right? Ay. So here will be another proc right. This will be on a file. We don't need provide a path, but we need content. Res the product content to the file, but it will be created. Okay. And we just need to do self fs write, and we have self path and this. So here it works. Why it doesn't work anywhere else? We export it. So our test right should be fine now. Yeah, that should be it. So let's copy it, and we'll have a bunch of correcting here, because this will be for number 2, but we'll do everywhere instead of using path absolute to write the file, we'll use path relative. So we need to do file system current directory is this, and we do path relative 1, and here we're creating a file path relative 2, because the file system is still the same, so we don't need to change that. Okay, that's it. I hope. Should write to a new file via absolute path. Let's ignore this whole relative absolute. Write to a new file. So let's do it like this. Let path relative is text file 3. Absolute content will be here. And then we do check not exists. Fs and file exists. And that'll be the path that we have here. We make sure the file doesn't exist, and then we want to basically write it. I guess we need to go with this relative 1, 2, and whatnot. Ugh. Okay. Check if it doesn't exist, and then we do basically write and check if it exists. And we do read all is content. Okay. Then we can do the second one. This will be B. This is number 2. And content, we don't need to redefine that. We just make sure it does not exist. And we can actually do that file is fs get file handle path absolute 2. So we basically check not file dot exists, and we do file write content and check the file dot exists, and we just check file read all. Again, we don't need any path here. Is the content. Okay. Just complaining about the file. Something is wrong here with this fs not being happy. Not sure right now. Let's continue. Should allow writing multiple elements. That's the big one. So let's do the same thing. Let's go for relative path, because why not? Okay, so let's do that. So now the content will be content 1. We test part 1. The content 2, content 3. And let's do content 4. Okay, and we're gonna do here, maybe it will be just number 3, and here will be an array of 1.6, 5, 1, 2.4, and negative 23.8. Okay, so we have string, integer, another string, and some floats. And let will be content is, let's just write it down, right? And then we have 3. Test this and that. I guess it's gonna print out like that, right? I hope so. So we have file 1, we create it. We check if it exists. And then when we write, instead of writing content, will be content 1, content 2, content 3, and content 4. This way we make sure that we can just type them like that with different types. And when we read it, it should be like content. And the same thing will be here. It's just will be file write, and file write will get all of those, take all those. Alrighty. That's how that works. We don't need absolute one here, not even. Awesome. Now, should throw an error when writing to the directory. So, let's just go with this absolute one. I'm just tired of doing testing for both this and that file, but I have to. So, these were... should be 4, A and B, okay. So this will be 5. Okay. So it should throw an error when writing into a directory. So in this case, we'll do let directory is fs create directory at that path. Okay. And we check if the directory exists, was properly created, right? And then we do write to that path. So should be expect a catchable error. And we just pass it this thing. All right. And yeah, that should be an error. Let's just make sure that after that, the file still doesn't exist. I mean, it can't. So check directory exists. Let's make sure it still exists. And then the second one, we have the same thing. We need to... oh, screw that. Let's just screw that. If it was an exception, nothing should happen in the first place. So we have this and that, and we don't need any A or B. Will be nothing matters here. And we create a directory and we try to write the file. It should fail, and then we should also do let file is fs.get file handle to that path, and we do expect catchable error when we just write the file. Okay, good. For some reason it just isn't happy about that, right? Huh. And it should create empty file when writing empty content. Okay. So where should write to a new file? Okay. Let's copy that part. And we're just gonna modify a little bit. Okay, so it should create an empty file. So this will be number 6, A and B. So we have those. The content will be, we don't need a content this time because it will be empty. So let's check if the file doesn't exist. Okay, and when we use write, the content should be just nothing. Okay, and which exists, and read all should be nothing. But it should create the file. Okay, and then we have yeah, the next file. And when we write to it, the content will be empty, 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 and empty. Okay, will be nothing, but 4 of nothing. And we check, and the contents should be empty. So that's that. And the last one, we need to test if appending changes something. So let's copy the one that has something like this. where we have just single path and single absolute and whatnot. So this will be 7 and content 1. Let's actually skip all that. Okay. So we don't care about directory. We'll just do file system write to the absolute path, and it will be hello space comma there. Okay. And here we can do check if it's hello there. If it actually wrote. Then let's just create a file for that thing so it's a little bit easier to work with it. I'll do file write, goodbye now, and expect that it's gonna be replaced, right? And maybe once more, file write, voila, right? Because why not? And it should be written like that. And that's it. I'm sure I made like 30 mistakes in this because that's my track record. It really complains about the file and file system because this whole write thing doesn't work for it. And I don't know why. We have normal proc defined on the file system. And as an implementation. Same thing here. Go figure. And this is already imported here, so that's not a good thing. Okay. So let's try to just reinstall it. Okay. And let's see what happens if I try to run it here. Bam, undeclared field read. Oh, okay, I see. CommonFs 11.3. Nope. Test right. 27.7. I think I know why I could expect that. 27.7. Check file, read all. And we have read all. Here we have read. Where else do we have just random read instead of read all? Here. We save it and we have a little bit less errors. Let's do read. Okay. Let's just go over all the instances of read if we have anything else anywhere. Nope, that's it. Save it, we redo it, and we try to rerun our test. What's going on here? Error, type mismatch. Oh, we're getting the same thing. Test, right. 33. Expression, right. File 2, path relative, content. Okay. Expect 1 or more. Okay. And it knows to expect this. It knows to expect this. Oh, because I give it a path. Ha. Probably that's why. So, line 33. There we go. File doesn't need contents. I mean the path, because it's obvious. And same thing goes here. Look at those errors disappearing one after another. Okay, nimble test. And now we have the normal proper errors. Passes should throw an error when writing into a directory. Well, it errored out because it's not implemented. So at least that's something we're passing right now. It's funny. Okay, let's implement it. So let's grab it from here. Right, implementation. Oh my gosh, that will be so easy. So we just go here. It'll be probably exactly the same thing. Right implementation. And we have this and that. Instead of file system, it will be OSFS. We don't need any of those. And we don't return anything. So it will be right. How is it supposed to work? In test all, we had it used. Write file. Okay. And that's literally it. So it'll be write file. And we're gonna get the absolute path, convert to a string, and the content. So we need to basically calculate the content. So for whatever text is, how do we combine it all? I'm sure there is a nice little something for it. Var args. What is the type of it? It's type var args. So let's just do the text is empty, right? And then for value and content. Okay. Text add. Is there something like text add? Yeah, concatenates in place. Perfect. And so we basically calculate the whole text. I'm sure there's just something to run on the whole thing, but we'll get there one point. Write file, and let's actually for now, let's just paste it here to see what our compiler will be unhappy about, because the compiler will let us know which errors we're not handling. So let's go here and let's try to nimble test. Can raise analysis exception, IO error. Okay. Again, that's probably about the path. So yeah, we just need IO error. And when I try to run that now, oh, that's it. Implementation right. Everything passed again. So I guess it overrides the file instead of appending. Good to know. Very good to know. Good. That makes me happy. I just don't like all those squiggly lines. They're just disgusting. Source OSFS name is specified as is that thing. Go figure. Okay. So, hey, we implement the second thing. So let's just go to our CommonFs. And let's go to our README. Let's just close it all up. Because we're finishing for today, I guess. It's nearly 1. All operations. Did we just check that off already? I thought we checked it off. Read all is done. Write is done. Oh, we checked it off for the file itself. Okay. So, yeah, now it's good. Okay. So that makes me very happy. I can go to here in CommonFs. We can basically specify that we implemented. Right. Okay. We push it. But before we push it on OSFS, I just, we have a few minutes before it's 1, before the end of the live stream. I want to check if I can do something else here instead of doing this for each, for adding. There must be something with string utils. I recall that if we go to the docs, we should be able to go to standard library. Isn't there like string utils? String utils, but there should be also like sequence utils. Sequence utils. We'll see in both, okay? So let's do string utils first. Converting, string concatenation, and checking for substrings. So let's see what we have here. Formatting. Format string. This and that. Oh, I see. Interpolates the format string. Okay, so we don't care about that, although this is awesome to know. Add F, add separate, align. Want something that joins them. Or maybe something like concatenate. It's empty or white space. This is exactly what it's in C#. That's funny. Okay. Join. Concatenates all strings in the container, separating them with a separator. I don't want to separate them. I just want to join them. Again, with a separator, so not that. Bool, float, repeat, replace, split. There's no C for concatenate like that? Huh. That's too bad. Too bad, because I hope that I would be able to do something like join, but without it. Oh, the separator is empty. But that means that if we're giving it a separator, it's gonna try to include it there. Therefore, we have a code that is less optimal. Can I see the source of that specific function? Runnable examples and result is for I here. I is 0. All larger than 0 and this, and then that. So we have additional statement here. And we just add to the result, just like we were so far. So, nope. I don't care about that. Our thing will be a little bit faster because we won't have this whole if statement. Okay. And if statement and adding nothing every time. So that's another thing. Cool. So our solution is a little bit better, a little bit faster. So I'm fine with that. Let's just remove that. It's fancier. Cool. So let's push that as well. I'm pressing wrong things everywhere. Drives me nuts. Okay. So OSFS here and test implementation can go away. Delete the file. It's just a binary. Implement write implementation. Okay. Push. And we can just double make sure that it still runs. Nimble test. Yeah. All tests passed. Gosh, that runs fast. Awesome. So that's that. We checked off 2 more boxes. Let me just look at what else we need to do. Because I don't think we have a lot left for basic functionality. For directories, I actually am looking forward to implementing walking directory and walking recursive. I believe we already have some functions for that provided by the what do you call it? By standard library, but I hope I'll be able to just return proper directory and file instances. So that'll be fun. Also, just iterating just over files or just over directories, and getting the parent of a directory. Maybe some of it I'll implement myself, but those iterators will be fun. And yeah, walk directory could be also walk files or walk something else. Yeah, we'll see. And then we have for file operations, we'll need to write the reading bytes and writing bytes. We'll keep it the same way it was so far. Later, maybe we'll extend the write or write bytes to the to something where we also specify if we're appending or if we're just overriding. Right now we're overriding, but we'll extend that. We just want something working so far. And the same thing, getting parent doc. And yeah, then we have all the additional things like getting the file size, getting the dates of last access, simple little things. No big deal. And yeah, I think we could actually have it all done by the next stream. I think it's possible to have all that done next stream. And the stream after that, we could focus on basics of permissions and see if we can figure out one of, either move or copy. I'll probably do the rest somewhere on my own time. And yeah, by Friday we might have this whole thing ready for publishing, and we'll be able to move on to the in-memory implementation, or just reworking the whole thing to be asynchronous. Because when you think about it, maybe here those file operations, that they don't necessarily need to be async, especially when you're working with something like SSD, also could benefit from that. But additionally, when you think about it, some other implementations will involve something like, getting a file from SFTP or an S3 bucket. Suddenly you have network involved, long delays. So it literally begs for it to be asynchronous, so you can do other stuff while you're waiting for your file to be downloaded or uploaded or something. So yeah, we might want to make it asynchronous. Make everything async. Okay. Oh, it read my mind. With this async will be interesting also how it works, because things like what do you call it? Like the current directory and stuff could be changed in between, so suddenly the implementations need to be kind of cached or whatever. An interesting subject to touch on. So maybe that will be Friday. We'll see. But that's it for now. It's time for me to finish today. So again, thank you for watching. And like and subscribe if you enjoyed the content. You can comment with suggestions even after the stream. And see you on Wednesday.